Hello everyone, myself Sankalp Rajesh Nigot and I am currently final year chemical engineering student at VNIT Nagpur. Today I will be giving a presentation on Karl Fischer titrator, its principles and application and techniques. It is an analytical instrument used to find the moisture content in the sample. It has wide variety of uses in different industries ranging from pharmaceuticals to oil and gas and cosmetic industries. Moving forward, here is the introduction on Karl Fischer titration. It is used to determine the water content in the sample. It gives us precise determine amount of water in the sample. Importance in analytical chemistry can be seen of this instrument as it is critical in quality control in industry level applications. We use Karl Fischer titrator as it has a cell like structure which avoids the moisture to enter the body. So, history and development of the Karl Fischer titrator. In 1935, it was discovered by German chemist Karl Fischer based on Bunsen's earlier iodine-based titration methods, and it helped us to brought the Karl Fischer titrator in existence. In the mid 20th century, various evolution took place in its design structure, and nowadays, furthermore advancements are going on its working on titration cell, its burette, and major applications on generator electrodes. So here we will come to the main principle of Karl Fischer titration. As we can see, a chemical reaction takes place where iodine reacts with the water content in the sample to determine the amount of water present initially. After reaching the end point of the reaction, we get to know the amount of water present in the reaction. This endpoint is determined by the presence of electrodes. Here the major reaction takes place between water and iodine in presence of SO2 to give us 2Hi plus SO3. Here the stoichiometric ratio of iodine and water is taken as 1:1, and the various side reactions which are involved are H2O plus I2 plus SO3 gives us 2Hi plus H2SO4, and the amount of electrode which is consumed helps us to determine the amount of water present. Types of Karl Fischer titration. Karl Fischer titration can be further categorized into two types. First is volumetric Karl Fischer titration and second is colorimetric Karl Fischer titration. First one, volumetric, is used for high content of water in the samples ranging from 1% to 100%, whereas colorimetric is used for very less water content, that is 1 to 5% in the sample. Also further use can be said that iodine is prepared in situ in colorimetric titrations. This is the major difference between volumetric and colorimetric titration. Then the components of Karl Fischer titration. It constitutes of titrator vessels, electrodes, and burette. Titration cell is where the reaction between iodine and water occurs. It is filled with the appropriate reagents and fitted with the electrode that detects the endpoint of the reaction. Coming next to the electrodes, in colorimetric titration or any general titration, the titrator reacts iodine and cell through the electrochemical processes. The amount of current passed through the electrode determines the amount of iodine generated. Then the burette. In volumetric titration, the iodine solution is dispensed from a burette into titration cell. The burette is connected to a control system that automatically adjusts the flow rate of the titrant based on the real-time titration curve. Further, various other another instruments can also be used, which are electrochemical detector, that is the electrochemical detector monitors which determine the presence of unreacted iodine. The detector sends a signal to the titrator when the iodine is fully consumed, indicating the end point of the titration. And in order to find the uniform mixing of the reaction, a stirring mechanism is also followed. A magnetic stirrer ensures that the sample and reagents in the titration cell are uniformly mixed throughout the titration process. The various reagents used in Karl Fischer titration are iodine, as it acts as an oxidizing agent, reacting with water. Second is sulfur dioxide, works with iodine to facilitate the reaction. Alcohol sometimes used for as a solvent for reagents, crucial for environment reaction environment, and reagent types. One two components with each distinct formulations which has to be identified is used. Then giving a brief on volumetric Karl-Fischer titration and colorimetric Karl-Fischer titration. First of all, we can see that in volumetric Karl-Fischer titration, titrant addition takes place. That is, titrant added to sample until reaction is completed. And second point is the endpoint detection, where visual or electrochemical indication marks the endpoint, and its application can be found in the industries which have high moisture sample like oil and creams. Also, this method can be briefly summarized as iodine is added as a titrant. The water content is calculated based on the volume of the titrant used. And moving forward, we have colorimetric Karl-Fischer titration. In this process, electrochemical generation of iodine takes place. This is also used for low content of water in initial samples, typically 1 to 5%. Here, endpoint detection takes place with the help of electrodes, as highly sensitive detectors are used, which confirms the endpoint with minimal errors. Application and limits can be found in pharmaceutical industry, but limited by equipment complexity, as we have to generate iodine in situ. Here, moving forward, we will see various advantages of Karl-Fischer titration. It has very high accuracy as it provides exact measurements crucial for assurance. We can also find that due to cell-like structure, the outside moisture also doesn't get inside the cell, which gives us precise content of water in the sample. Then the precision, consistent results are found, especially important repetitive testing scenarios on industrial level scale. Now sensitivity of the reaction, capable of detecting low level of water content with precision, and it is generally used to find the unreacted amount of iodine present in the sample. Advantages of Karl-Fischer titration. Karl-Fischer titration offers unparalleled precision in water content analysis. It's sensitive and accurate even at low concentrations of water, crucial for quality control in sensitive applications. Then some limitations and challenges which are faced by Karl-Fischer titration. Chemical interference. We can see that chemical interference can take place if initial sample consists of another materials as compared to water, which will react with the iodine to form different products, giving us a wrong result about endpoint, and we cannot get 100% accuracy. So as a predictive measure, we have to get the sample out of impurities. Second is environmental sensitivity, requires controlled environmental conditions for precise measurements. Hence initially we were using SO2 gas as in order to maintain the proper environmental conditions for performing the Karl-Fischer titration. Now the equipment complexity. Specialized equipments demand regular maintenance and skilled operators. Continuous maintenance of electrodes, cell has to be done. Regular washing of the cell has to be taken place in order to prevent corrosion. Also, in complexity increases in case of colorimetric titration, where we use in situ production of iodine for the chemical reaction, as it contains very few amount of iodine present in the sample. Also, applications in various industries. We found application in wide variety of industries for Karl-Fischer titration, ranging from pharmaceuticals, chemicals, food, and oil. In pharmaceuticals, it ensures optimal moisture levels in drugs and APIs by removing the water, and to find a proper product for consumer side, we have to first of all find the amount of moisture in the sample, which determination helps by Karl-Fischer titration. Secondly, in chemical industries, it determines the solvent and polymer water content, which is generally useful for production of polymers. In foods, it maintains the food quality and shelf life, as water present in the sample can damage the food content. Also in oil and gas sector, it measures the water in oils, fuels and lubricants. Now, in detailed application in pharmaceutical industry can be found in drug quality. Karl Fischer titration helps in monitoring the drug stability and composition. Also, in active pharmaceutical ingredients, determines the moisture level in raw APIs to ensure its purity and effectiveness. Then, in chemical industry applications, it can be further seen in solvents where we effectively identify the water content to maintain its solvent's purity for further use. Polymers. It ensures polymer structural integrity and performance by monitoring the moisture content in it. Functional chemicals, key in creating components with precise moisture specifications. Food industry applications. We can find that in food industry, water content should be optimal or as per needed, or it should be zero, as presence of water in the food sample can degrade its shelf life or it can degrade the food quality. So we have to always keep a check on water content, and this is done by Karl Fischer titration. The major things that we look for are quality assurance. It confirms the optimal moisture levels for food safety and quality. Second is the shelf life. Accurate water measurements prolongs the food freshness and stability throughout the longer period of time. And flavor preservation. It preserves the intended taste profiles by monitoring the water content, and product can last long as well as its flavor is preserved throughout the period. Now we can see its use in oil and petrochemical industry. In oils, we can say that it maintains lubricant efficiency by regulating the water levels. In fuels, it assures fuel quality and performance stability by finding the appropriate water level in the sample. In lubricants, it prevents machinery corrosion caused by excessive moisture, as lubricants are widely used in order to prevent the friction, but the use of water or in the sample can lead to the various problems like corrosion and erosion of the machines. Accuracy and calibration has to be done in order to uh, run the reaction smoothly, as well as to keep the equipment safe from corrosion. So regular calibration is essential for maintaining the precision and reliability of results, as it is highly precise. In order to keep its precision and accuracy, we have to keep regularly calibrating the sample. Best practices are avoiding the drift by calibrating frequently and using fresh reagents. Also, we have to maintain the industrial standards by adhering to industry standards for consistent measurements. And we have to also look for various common issues which are generated using the various electrodes or the side reactions which are occurring in the reaction cell or the reagent degradation. In electrode problems, we have to inspect and clean electrodes regularly to ensure its functionality and to avoid further major problem. Side reactions, which we have to identify and mitigate unwanted side reactions that affects the results. Hence, we have to ensure that our feed consists of pure sample, except water. There should not be any impurities. And reagent degradation, use only fresh reagents to prevent degradation impacting the accuracy of Karl Fischer titration. Then future of Karl Fischer titration can be summarized as with the help of AI and other advanced automation, the Karl Fischer titration helps us to reduce our error, saves our time, boosts our accuracy. Digital transformation is also going on in this sector, where digital titration systems offer more data insights and control, and it is highly precise over the analog systems. Then it also provides us sustainable practices, as it is exploring the eco-friendly alternatives to traditional reagents and traditional titration other than volumetric titration and colorimetric titrations. Conclusion and question answers. The key takeaways can be found that Karl Fischer titration is an important analytical instrument used in industries to find the water content in the sample, and it is highly precise and accurate. Hence, it is used in wide variety of industries ranging from pharmaceuticals to oil and gas sector. Hence, this was about Karl Fischer titration. Thank you.